Hello students, welcome to the online tutorial session. Today we will learn about the various type of networks, about the terminology and different type of transmission method. Okay, so earlier till date we have learned about the distance based network classification, that is different LAN, about the LAN, MAN or these things. And the topology based network classification we have also learned. Bus topology ring we have completed. But today with the first topic for this session is, that is communication based network classification is there, and another the terminology. Okay, so first we will learn about the different terminology. Okay, so this the first one is, that is bandwidth. Okay, so what is actually the bandwidth? If you are able to see the picture, okay, then so bandwidth of a channel indicates the range of frequency that a communication channel can handle with a reasonable reliability. Reliability means that how actually the product, or you can say service, you can trust on. Suppose if you're working with a software, so if you're giving input 100 times, so it will give you the result 100 times true, then you can rely on it. Or it will give you 99% times output correct, then you can rely on. Otherwise you cannot rely. It is not a reliability. So that is the reliability. Okay, so how we can do it, or you can treat the bandwidth as a physical property of the transmission media. It is actually the difference between the Fmax minus Fmin. Fmax is the actually the highest frequency and Fmin is the lowest frequency. Okay, so difference between highest frequency range and the lowest frequency range, or maximum frequency or the minimum frequency. Okay, so this can be measured in terms of hertz. Okay, so in case of the majority frequency in the human voice lies in the range of 400 to 3400 hertz. Okay, maybe my mine one is more than 3400 hertz. Okay, jokes apart. Now so why actually we need to learn this bandwidth terminology? So the rate of transmission of the data is directly proportional to the bandwidth of the channel. So more the bandwidth, more the data carrying capacity. So okay, if the bandwidth is very big, or okay, so range is very big, then it can carry the data smoothly. Okay, now coming to the next one, that is the signal to noise ratio, or you can say it is SNR. Okay, it allows the signals to be transmitted over a long distance with a sufficient degree of accuracy. Okay, so actually it is easier, actually larger actually frequency, it will help us so that we can detect the frequencies from the receiver, and it will be easier to detect. Okay, now what is the channel capacity? So channel capacity of a channel indicates the maximum number of binary digits that can be transmitted through this noisy communication channel per second with minimum error. Okay, so it is measured in the bit per second, or you can say that BPS. Okay, now coming to the baud rate. Okay, so what is baud rate? Baud rate of a channel indicates the signaling speed of a channel, that is the number of data symbols or the signal transmitted by the channel per second. That is the in case of capacity, don't mix it with this term. Okay, channel capacity is a maximum number of digits. Okay, and here is the number of data symbols or the signals, okay, transmit per second. So how can we differentiate between the bandwidth and the baud rate then? Okay, so bandwidth, the concept is usually used in the telecommunication theory to indicate the range of frequency that can be transmitted through a particular channel. And the baud rate, the concept is indicate the signaling speed of a digital communication. Okay, communication line. Okay, in case of bandwidth, the channel whose bandwidth is B can transmit at the rate of B bits per second. B means take as B, there will be number. Okay, and N baud lines transmit at a rate of N signals per second. Okay, now third point, in case of digital communication, it indicates the maximum number of bits can be transferred through a channel per second, and in case of digital communication, baud rate means the number of times the signals can change its value per second. Okay, it is measured in hertz or beats per second, and it is measured the symbol per second, where each symbol can be encoded more than one beat. So now coming to the next topic, that one is known as the communication based network classification. Okay, under this communication based classification, there are two type of network is available. One is point to point, another one is multi-point. Okay, communication. So first we will read about the multi-point, and then we will be moving forward to point to point. Okay, so this point to multi-point network is also called a multi-point network. So point to multi-point or normally multi-point, both are the same. Okay, so in such a network, data is transferred from one signal location or a node to the multiple location. As you can see, there is a base station is there. In the picture you are able to see one base station is there. See this one. Okay, and 1, 2, 3, 4, the radio cars or sector antennas are there. Okay, so it is transmitting to the all four. Okay, from one source to the several destinations. Okay, so via a different path. It is not that they are actually transmitting the signals on a similar path. No, they are following the different paths. So this is actually mainly used for the wireless communication, where the central antenna broadcasts the data to the several sources. Okay, transmitting the signals using the wireless modem. Okay, so this is the point to multi-point. Okay, now coming to the point-to-point connection or P2P connection. Okay, so in such network, the communication takes place between two endpoints. Okay, here multiple stations are not involved. Okay, data is transferred by one computer and received by another computer only. Okay, so see here over here. Okay, amber crystal radio with the integrated antenna, and here is another one. Okay, radio antenna with the integrated antenna, here is another one. Okay, so only two devices is involved over here, and transmissions can happen between these two only. Okay, so the communication can be both ways, but in signal direction. A can transmit to B, B can transmit to A, but in a single direction, not in a both ways direction. Okay, so the two distance computer can also be connected using the lease line or the modem to form the point-to-point network. Okay, so now we will differentiate between these two. So first is link. Okay, so this is dedicated link between two devices in case of point-to-point. In case of multi-point, there is a link shared between more than two devices. Okay, channel capacity, that we have learned this term channel capacity in this lecture. The channel's entire capacity is reserved for two connected devices, but here the channel capacity is shared temporarily among all the connected devices. Transmitter and the receiver, here the single transmitter and single receiver is there, but here the single transmitter is there but multiple receiver is there. Example, you can say frame relay, T carrier, or frame relay, token ring, Ethernet. Okay, these are the examples. Now coming to the different transmission methods. Okay, previously we learned about this transmission half nuclear simplest. Don't get confused over these two terms. Okay, there is also a transmission, here is also one transmission method. Okay, so that one is actually the communication mode, okay, and this one is the transmission method. Okay, now this is the first one is serial transmission. Okay, so in this type of communication, information is sent one bit at a time serially through a single communication cable. Okay, so suppose a 8-bit information is there. See over here, 0 1 0 0 0 1 1 0. Okay, it is there. So what are we going to do? So the 0 1 1 1 1 0 1 like this there. So what we're going to do? We have to transfer each bit, first 0, then 1, then 1, then 1 single bit at a time. Okay. So a serial mouse is such a device where the data from the mouse is transmitted to the computer through a serial cable. Okay, so what are the advantage you are getting over here? Since the signal cables can be used for serial communication, the cost of a setting up of serial communication is lesser. Okay, computing overhead also less, but disadvantage is what? That the computer data for parallelly, hence the data flow needs to be converted into parallel to serial and vice versa. So we have to conversion need to be there. Okay, so in case of parallel transmission, what is going on? So in this type of communication, multiple bits are sent at a given time. Suppose a 8-bit information is there. In a one shot, you can transmit it parallelly. Okay, so that's it like this: 0, 1. Every bit is going. Every bit is going in a one way. Okay, at a given time, all bits can be transferred through a parallel communication line, with each line carrying a single bit. Therefore, the data transfer rate of a parallel communication is higher than the serial communication. Advantages: what? The number of bits transmitted per second can be more than the serial communication. Disadvantage is what? Since the multiple lines are required to be transmitted, the cost of parallel transmission will be higher. So as we have learned what is serial communication and what is parallel transmission, now we try to differentiate between these two. Okay, so in serial transmission, data, it means B, that is digit, flows in bidirectional. Okay, and in case of parallelization, data flow in multiple lines. Okay, number 2, in serial transmission, cost is actually efficient, but it's not efficient because it's high. Number 3, 1 bit transferred in a 1 clock pulse, but here 8 bit is transferred at a 1 clock pulse in case of parallel. In case of serial transmission, it's a slow comparison to parallel, and comparison to serial, parallel transmission is fast. Okay, but serial transmission is used for the longer distance, and the parallel communication is used for the shorter distance. Okay, so circuit for the simple transmission, that side is simple, but in case of parallel transmission, it is a relatively complicated. Okay, now coming to the different modes. Okay, so we know about the communication transmissions method, but in which mode they are doing this transmission? Okay, they are doing in two ways. Okay, two modes are there. Okay, so one is the synchronous transmissions and another one is the asynchronous transmissions. Okay, first we will learn about the synchronous transmission. Okay, this is an efficient method of transferring the large block of data. In this mode, before the data is sent, the sender and the receiver first is synchronized with each other with a digital clock signals. Okay, what do you mean by the synchronization? That both the sender and the receiver must agree with some protocols or some rules. Okay, maybe they said I will send 3 blank signals, and after 3 blank signals, you whatever information you are getting, that is actually the real one. There must be some sort of agreement between the sender and the receiver must be there. Okay. Okay. Only after sender and the receiver is synchronized. Suppose 12 o'clock they will send. They have done an agreement that at 12 o'clock the data transmission will be start. So whenever they get this notification, they will, its receiver will start giving the data and sender will receive the data, some sort of. Okay, so so this is similar to making a telephone call. So like a caller dials up the number and forms a connection with our caller number, then start the conversation. After the conversation is over, both the person disconnect, but the connection remains active till the full conversation is over. Till the data transmission is going on, it is active. But as soon as the transmission be received by the receiver, then and sender also done with the sending of the information, both the end it will be they will be disconnected, but the connection is exist. Okay. Okay. Now coming to the asynchronous transmission. This refers to the transmission of information between two devices that are not synchronized with each other. There is no agreement between them. Okay. So it means any of the clock signal or any other mechanism. Okay, so they are not actually synchronized by any clock pulse or any signals or nothing. The sender can transmit the data at any time, while the receiver must are ready to accept the data when it's arrived. So sender must be alert mode. Okay, when receiver sender don't know when the receiver will start the transmission. So it may be in the alert mode. Right now the data will come. Right now data will come, like this. Okay, any point of time sender can send the data and the receiver must have to receive the data as soon as it arrives. So that's why in this transmission, this kind of a transmission occurs using the data packets. From the beginning, when I started the chapter networking, I have told you that in case of network, the information are actually passing as a data packet, small packets. Okay, and usually is used for the serial communication. Okay, so how actually this data packet is designed, I will show you. Okay, and how the data packets occur. Okay, I am using a different color. Okay, I am using the blue, yellow one, that will be helpful. Okay, how the message is going. Okay, I am designing the window. Okay, that one is the S bit. S bit means start bit. Okay, now is the actual MSG. MSG means message. Now is the parity bit. Parity bit means the, I'm telling, and the stop bit. Parity means they're pure. Okay, parity is there, and now is the stop bit. Okay, where to stop, because it is a packet. As they have to denote the end of a packet. Packet after packet they are sending. So this one, this bit will denote that this is the end of the packet. Then there will be a idle time gap. Okay. After then again start bit, again MSG, again parity bit, again stop bit. Okay. This total thing as named as data packet. Okay. So what will be there in the data packet? I hope you understood. Okay, so parity bit is what actually check. It's a bit to check if any error is there in the transmission. Any transmission errors is occur, because when it is coming in a packet, maybe one packet received earlier, maybe some packets are missing, maybe the information may be missing or something. So that's why one parity bits are there that includes to check if any transmission error is occurred or not. Okay. I hope you have understand these things. Okay, transmission. Now coming to the differentiation between these two. So clock pulse, in the first form clock pulse subject, the transmission and receiver share the common clock pulse, but there is no common clock pulse present in the asynchronous transmission. Speed of transmission in case of synchronous is fast, and in case of asynchronous it is comparatively low or slow. For form of data transmission, data is sent in the form of frames or blocks, and data is transmitted in the form of bytes or characters. Time interval, it is constant, it is variable. Okay, cost is very expensive, synchronous one, as they have to synchronization has to be stayed and then the transmission. Okay, comparatively less expensive than synchronous one. Okay, time interval, it is a constant, and this one is a variable one. Okay, why vary? You don't know that after one data packet will receive in how many times, you don't know. Then first after the first data packet there will be interval, so you cannot count the After 10 minutes, one packet will be received, then will be 5 minutes delay, then the second one, no, we cannot count. That's why it is variable. Okay, efficiency, asynchronous one is the most efficient one, and compared to the synchronous, asynchronous is less efficient. Need of external clock, it exists in case of synchronous, but asynchronous, no concept of clock pulse or clock signals. Okay, need of start and stop bit doesn't exist over here. Okay, but in case of asynchronous, start bit and stop bit is required. Okay, and circuit is more complex in case of synchronous one, and comparatively less complex in the asynchronous system. Okay, now we will learn about the different transmission, that is the baseband transmission and the broadband transmission. So first we will learn about the broadband transmission. Okay, so data transmission speed at least 256 kbps are termed as the broadband, that we are using, like broadband internet connection. Using broadband communication, the information is usually sent over multiple channels, thereby increase the overall bandwidth. Hopefully you understand the concept of the bandwidth now. So however, bandwidth channels transmit analogous data are unidirectional in nature, meaning both way, okay, at the same time. Okay, hence two different channels are needed for the transmission of the signals in two different directions. Okay, so what are the characteristics? I am saying that is the analog signaling is there, transmission is unidirectional, signals traveling distance is long, frequency division multiplexing, that I come just after that, this one I will explain. Okay, so transmission of a multiple signals over different frequencies, and used to they like example like TV we are doing now. TV premises, TV that we are broadcasting everything, that one is a broadband. Okay. Now come to the baseband. It's a digital signal transmit the medium using the signal code like NAR, NRZ, Manchester Piper's encode is a very hard term for you right now. But just to remember that this refers to the situation where the entire bandwidth of the communication channel is used to send only one digital signal. Okay, and the baseband channels are the bidirectional in the nature. Here digital signal is there. Okay, frequency division multiplexing is not possible over here. It is a bidirectional as I mentioned. Okay, shorter distance signal traveling is there. Okay, entire bandwidth that I am telling. And now example is that Ethernet we are using in LAN, that one. Now come to the difference between these two. Type of signaling, baseband is a digital one and broadband is an analog one. Application is, it is worked with a bus topology and it is can be was bus as well as the other topology as well. Encoding use, Manchester encoding is there, and here it is PSK encoding is there. Transmission, it is a bidirectional one, this is a unidirectional one. Signal length, signals can be traveled over a shorter distance and signals can be traveled over the longer distance without any attenuation. Attenuation is not required over here. Now come to the different part, that is the frequency division and the time division multiplexing that I am talking about in this previous. Just now I have talked about the different. So first we have to understand what is the meaning of the multiplexing. Okay, so multiplexing is used in the case where the signals of lower bandwidth and the transmitted media having the higher. When you are transmitting the signal, that is in the lower bandwidth, but where you are actually transmitting, that is having the higher bandwidth. Okay, so in this case, the possibility of sending number of signals is more. In this, signals are combined into one and sent over a link which has a greater bandwidth of the media than the communication nodes. So now, coming to the different type of multiplexing. First one is the frequency division multiplexing. In every M, the different frequency are used to carry different signal generated by each transmitting device. A multiplexer is used, you know the use of a multiplexer. Okay, so a multiplexer is used to modulate each carrier frequency with an input signals and then transmit them simultaneously across the channel. So it will take several uh, signals and transmit to the required destination. At the receiving end, the demodulator will be there, or demultiplexer circuit will be there. Use the exact data signals from signals from the different carrier frequency. And the okay, in the diagram you are able to see this one. It will taking the multiple inputs, and then it is transferred to the multiplexer, as well as it is reached to the destination, and one demultiplexer will be there. They will extract the from which carrier the which frequency and coming, and according to that they will send it to the channel. Okay, now coming to the time divisional frequency. In TDM, a particular p-assigned time slot is assigned in each transmission node. The total time available in the channel is divided between the several users. So each user of a channel is allotted the time slices during which it may transmit its data. Thus, the several data streams are joined serially to form a signal data stream and get the transmitted. Okay, here actually baseband concept is used. Here time slot is there. Okay, one time slot is for this channel, second time slot is this channel. In this way, it is given. Thank you, students. I am ending my lecture over here.